Hi, I'm Jack Horner. I'm a paleontologist. I worked as a curator of paleontology at the Museum of the Rockies, Montana State University in Bozeman, Montana, for about 34 years. And my job there was digging up dinosaurs and doing research on them and writing papers, writing books. My specialty on dinosaurs has always been their social behavior, how they cared for their babies, how they grew, and stuff about their evolution. I worked also on the Jurassic Park movies, all 5 of them at that time. So there was Jurassic Park 1, 2, and 3, and then Jurassic World 1 and 2. My job was, I was hired by Steven Spielberg to put a little bit of science in the movie. They are fiction; they're not accurate. So my job was to make sure that the dinosaurs looked as accurate as they could, based on certain factors. So I want to, they're not accurate. They're more accurate than some people might have thought dinosaurs looked back in the 90s, but for all intents and purposes, they're not accurate, because even in the 90s, in 1990, when we really started working on the movie, we already knew that velociraptors and things like that had feathers, but there were constraints in both computer graphics and in the animatronics, the big mechanical puppets that they used. There wasn't really any way to put feathers on these creatures, so they don't have them. If we were to make a new Jurassic World, which they are working on, I'm pretty sure that they will put feathers on them. I have always wanted to be a paleontologist my whole life. And when people ask me, why did I want to be a paleontologist? What sparked my interest? Nothing really did. I was born this way. I found my first fossils when I was 4 or 5 years old. I found my first dinosaur bone when I was 8. I found my first dinosaur skeleton when I was 13. And I've been collecting dinosaurs my whole life. One of the things that while I was working on Jurassic Park, so I had been this paleontologist. I dug up dinosaurs all over the world, did a lot of research in Montana, and wrote books about dinosaurs. And I was always fascinated by them as living animals, and my research on their behavior and how they grew. It was I had artists working with me, and I would get them to depict these scenes of what dinosaurs were like as living animals. And when I got to work on Jurassic Park, that allowed me to actually, help in the design of what these dinosaurs look like, and be able to experience them up close. I mean, the puppets, these large mechanical puppets, were life size. So there I was, face to face with a Tyrannosaurus Rex, in extreme detail. The artists had created this incredible animatronic beast that could move, and his eyes would blink, and the texture of his skin would ripple a little. I mean, it was a very accurate rendition of a Tyrannosaurus Rex for the time in 1990. And so, it was fascinating for me to be with these dinosaurs, to see what they were like as living creatures. But, you know, there's never enough, right? We paleontologists, we always want more. And so I got to thinking when we were working on Jurassic Park that, birds are living dinosaurs, and that means that, that birds are related. And and one of the interesting thing I was one of my students at Montana State University when we were working on Jurassic Park. One of my students was Mary Schweitzer, and Mary Schweitzer is a very well-known paleontologist now, and she looks at she's into looking at soft tissues and biomolecules in dinosaurs, and at the time, she and I and another fellow got a grant from the National Science Foundation to see if we could find DNA in dinosaurs, that go along with the movie. And so, we did that. We looked for DNA, but we couldn't find it. But Mary would go on and find soft tissues, what we think are soft tissues, and proteins and things like that in dinosaurs. And it was a major discovery, but no DNA. So no possible way to make dinosaurs the way they were made in the movie. But it got me to thinking about, was it possible to make a dinosaur? Would it be possible to bring dinosaurs back? And because they're related to birds, seemed like, there might be this possibility. Genetic engineering is something we do with plants. We genetic engineer plants. We even genetically engineer some animals. I mean, we've taken genes out of one organism, like corals and things like that, and put them in some other animal, like a fish, glow genes, and actually made fish glow in the dark. And so, genetic engineering does go on, and it just seemed like it was something that was worth pursuing, looking into. And so, when we were making Jurassic Park 3, I actually wrote a book called with Jim Gorman on how to build a dinosaur. And it talked a lot about how we might be able to go about making one. I gave a TED Talk later and on the whole subject of what it might take to make a dinosaur. And in 2012, I acquired some money. George Lucas gave me a pile of money and said I could do anything I wanted with it. And so I initiated what we call the Dino Chicken Project. And the idea really is to see if we can make a dinosaur, bring one, not bring one back from the past like they did in Jurassic Park, but see if we could find some of the characteristics that dinosaurs had that birds still might have. In other words, see if some of the genetic pathways that dinosaurs had might be preserved in birds. And so that's what the Dino Chicken Project was all about, was seeing if we could figure out whether we could discover in birds some of the characteristics that dinosaurs had. And so that's what we set out to do. It was, as you can imagine, it's a very controversial project. It is genetic engineering. It's not quite the kind of genetic engineering that, some people think about it. What we're really doing is trying to find these atavistic genes. And atavistic genes are genes that basically have been turned off. There are genes that did something in an ancestor, like dinosaurs, and and were turned off in the course of evolution as dinosaurs evolved into birds. And so, as some dinosaurs evolved into birds. And so, what we've been doing is seeing if we can find some of these atavistic genes, and since they've been turned off, see if we can turn them back on and get some characteristics, some dinosaur characteristics in a bird. So if you ever look at, like, we use chickens, right? And we use chickens because we have to get their eggs, and a viable chicken egg costs about $5. We could use other kinds of birds, but their eggs are extremely expensive. So $5 chicken eggs are the way to go. So so basically what we do is, we get some chicken eggs that have embryos growing in them, and we go into that embryo, and we put some markers in there. We determine what genes are turning on at what particular time, and we see if we can alter when certain things are going on, and that really is what it's all about. Like I say, it's controversial. There's a lot of people that don't think that anybody should be messing around with animals. They don't seem to mind plants, but people don't like scientists messing around with animals. And there may be some reason why you shouldn't, but on the other hand, everything we learn about an animal by looking at their genetics helps us, right, with ourselves. I mean, one of the things that we've been looking at their dinosaur, excuse me, looking at how the tail grows, and how dinosaurs lost their tail, why it is birds have this really short tail. And in doing that, in studying the tail, we've discovered what we think is one of the causes of a major genetic disease in humans, and that's ankylosing spondylitis. We think we know what causes that in birds, and we think that the same genetics is probably causing it in humans. So there's a lot of discoveries that can be made in this kind of research that would be very applicable to humans. And so I'm a advocate of discovering everything we can discover. I don't think there should be limits on discovery, but that is a matter of opinion. Anyway, that's kind of what that's basically what the Dino Chicken Project is about. We've never hatched one. We've never hatched we don't let them develop very far. We go in, we put our markers in, and let it develop a little bit just to see what's going to happen, and then we terminate the embryos. And they're terminated at a very young age, so we don't mess around with highly developed organisms. So anyway, that's the kind of things I do, and that's the kind of research that we're interested in, and I still dig up dinosaurs. I mean, in the summer times, when we're not in a pandemic situation, I still work on dinosaurs and still trying to figure out how they grow and how they evolved, and just basically anything we can discover.